Okay, so today we're going to go through the concept of limiting and excess, and I'm also going to walk through an example in real life, so make sure you have your data booklets out so you can follow along with me, and hopefully this will all make sense. Okay, so when you're taking a look at the concept of a reaction, it's very simple so far, because so far what you've had is you've had reactions where it'll say something like 3 grams of substance A reacts with an excess of substance B. You probably didn't even clue in that part was in a word equation where it's in an excess of. But in all reactions, we have a situation like this. If you take a look at this Lego situation, I'm going to show it to you in the Lego situation. These guys, because they're on, let's pretend this is like an arrow, because now we're kind of comparing this Lego situation with reactions, right? These are your reactants. So you have your reactant A and you have your reactant B. You'll notice that there's 3 Lego, 1, 2, 3. You know how Lego works. They're going to clip onto 1, 2, 3. So these are one of your products, or this is your product. And here, what we have is we have a little extra. This little extra, kiddos, is the excess amount. So if I go back into the reactants, we can be like, okay, that substance here is in excess, and this substance then is limiting. So this is where these words come from, a limiting reagent and an excess reagent. Sometimes it tells you, it'll be like, oh, this many, 2 grams of this substance reacts with an excess of this substance, okay? But typically, when you have a balanced equation, let's take a look at this balanced equation here. We have hydrogen gas plus oxygen gas is going to yield water vapor, for example. Okay, now, this is what you really need to understand. This balanced equation is representative of millions and millions and millions of hydrogen particles and oxygen particles creating water particles, right? This is just a representation. This is just kind of like saying, hey guys, this is what happens. But this will happen thousands and thousands and millions of times, like over and over and over again, because it's so vast, the amount of hydrogen and oxygen available. So I've given you kind of like a little example. Let's pretend this is our hydrogen. This is our oxygen, right? When these guys come together, we create water. In this example here, let's just pretend that in this example here, this is all we have. This is what we have access to, okay? So here's our oxygen. We only have three particles of oxygen and 4 molecules of hydrogen. When I make water, here's a water, here's a water, here's a water, here's a water. What's this? This is what is in excess. You can't tell by looking just at what's available. Because if you take a look at what's available, you'd be like, oh, I think oxygen is the excess, or the limiting, right? Because there's less of it. But you can't look at it that way. You have to be like, whoa, wait a minute. Let's go into our balanced equation and figure it out. And when you figure it out, you realize that oxygen, in fact, is what's excess, okay? So what you have to do, what we have to do, is we have to learn how to identify the limiting and the excess, okay? Why do we care? We also care because when we are creating a reaction, we have 2 reactants, right? We have to make sure that one of those reactants reacts 100% of the time. So what you have to do is you kind of have to give the other reactant a little more for insurance sake. Here's an example. Let's say I want to make you guys peanut butter sandwiches. I would, of course, ask you, hey, anybody allergic to peanut butter sandwiches? Well, let's say there's 48 of you, so that wouldn't happen. You wouldn't even fit in my class. But let's say I have 20 kids in my class, right? I for sure know that I need 40 pieces of bread, right? That's for sure, and that's not hard to do. Okay, 40 pieces of bread, that's my limiting. I'm going to use up 40 pieces of bread. I have to use up 40 pieces of bread because to make a sandwich, I need 2 pieces of bread per kid. Now, if I'm making a peanut butter sandwich, I also need to have a jar of peanut butter. All right, there's my jar of peanut butter. What I have to ensure is I have to ensure that there's exactly enough peanut butter and more to make those 40, to make those 20 sandwiches. Make sense? So let's say that I'm like, oh, for each sandwich, I'm going to measure out 5 milliliters, right, of peanut butter. Okay, that's cool. So if I do that, I know I'm going to need 250 milliliters of peanut butter. But am I going to exactly measure out 5 milliliters per time? No. So I'm going to have to give a little excess. So in the chemistry world, we usually give about 10% extra. Okay? So in general, the rule is to assume that a reasonable quantity of excess reagent is to use about 10% extra to ensure that the limiting gets all used up. So when you know the quantity of more than one reagent, you may need to know which one will limit the reaction. So when you're creating the reaction, you have to just make sure that one of those reactants, you're going to bump it up a little bit to ensure that the other reactant gets used up. But when you have a situation like this, right? For example, let's walk you through how we would do this. You want to test the stoichiometric method using the reaction of 2 grams of copper to sulfate. So I'm going to highlight that. I have some information. In solution with an excess of sodium hydroxide. Okay? Excess, which means that that has to be my excess. What would be a reasonable mass of sodium hydroxide to use? If we use the exact amount, right? If we use the exact amount, here's our stoich. Here's our balanced equation. Here's our populated equation. I have 2 grams of copper 2 sulfate. This is my molar mass of copper 2 sulfate. I want to know the mass. Well, you know how to do this. You just take your molar ratio to go from moles of copper 2 sulfate to moles of sodium hydroxide. Well, that's my mass, right? Here's the thing. I can't vouch 100% that this is a pure substance, like a pure solution, and that this is a pure solution. I can't say for certain that I'm going to measure exactly 2.00 grams. I can't know for sure. So I'm going to bump it up 10%. So instead of measuring out 1 gram of this, I'm actually going to measure out 1.10 grams of this. I have a little bit of insurance to make sure that this whole 2 grams gets used up. So that's why we have a limiting in excess. Okay? All right, let's do another one. For example, if I have 10 moles of methane and 10 moles of oxygen, which of these two is my limiting? Now, this is where you have to pay attention because this is where the magic happens. Obviously, I have 10 moles and 10 moles. No idea, right? Which one has more? Or which one's the limiting? Which one is the excess? So what I have to do is I have to compare methane to oxygen. Then I have to compare oxygen to methane. Allow me to do this. We agree that I have 10 moles of methane. There it is, right? And I want to know how much oxygen I need. So if I have 10 moles of methane, then I'm going to use my molar ratio. This is what I have, right? CH4 is what I have, and this is what I need. Okay, that's where that comes from because that's what I'm looking for, and this is the 10 moles of the methane, which is what I need. So if I use my molar ratio, I know that I need 20 moles of O2. Okay, it makes sense, right, kiddos? Now, that's really telling me nothing yet. But now what I'm going to do is I'm going to compare my oxygen to methane. So now we went this way the first time. This time we're going to go this way. So I have 10 moles of oxygen. I'm using my molar ratio. This time oxygen is what I have, right? So now the 2's on the bottom because it's of O2 and this is of CH4. I need 5 moles of CH4. Now, this is what you have to do in order for this all to come together. Okay, and I actually put squares in my work because I want to make sure I don't make a mistake. So look at what happens. This is the beauty of chemistry, kiddos. I have 10 moles of methane. How many moles of methane do I need? I only need 5. I have 10 moles of oxygen. How much do I need? I need 20 moles of oxygen. Okay, so This is what we have to think about. Since 20 moles of oxygen is required to react with 10 moles of methane, but only 10 moles is available, oxygen is my limiting. Okay, oxygen is my limiting because you have less than you need. Put a little happy smile. That's it. Because I have, let's go again. I have 10 moles of methane. I need 5 moles of methane. I have more than I need. I have 10 moles of oxygen, but I need 20. I have less oxygen than I need. Oxygen is my limiting. All right, now let's go through this, but this time we're using grams. So but it's the same concept. I have 10 grams of copper. If I have 10 grams of copper, it's placed in a solution of 20 grams of silver nitrate. Which reagent will be the limiting reagent? Okay. Alrighty, so let's take a look. Basically, this is what we're going to do. All reactants must be converted to moles, then using the mole ratio, determine which reactant we're going to know first. Great. That's awesome, but let's take a look at what that looks like. There's my balanced equation. That's very important. Then you're going to populate the equation, kiddos. You're going to populate the equation. 10 grams of copper. Yeah, got it. I have 20 grams of silver nitrate. Got it. Here's my molar mass of copper, and here's my molar mass of silver nitrate. Okay, now what you have to do is you actually have to compare the copper to the silver nitrate and then the silver nitrate to the copper. So the first way we're going to go is we're going to compare. I have 10 grams, right? There's my 10 grams. Here's my molar mass. My grams cancel out, and that's my moles. You have to get to moles, kiddos. I have 0.157 moles of copper. Here's my molar ratio. Here's my copper, and here's my silver nitrate. And this is what I need of silver nitrate. So far, it's not telling you much, but it's almost there. We're almost there. Now I'm going to go the other way, right? Remember? Now I'm comparing silver nitrate to copper. So I have my 20 grams of silver nitrate. There's my molar mass of silver nitrate. I have 0.118 moles of silver nitrate. Right? Now I'm going to figure out how much I need of copper. So here's my copper, here's my silver nitrate. And remember, that comes from the balanced equation, right? So this is what I need of copper. Now, do you remember what we did last time? I'm going to compare what I have and what I need of each. So I have 0.157 moles of copper, but I need 0.0589. I have more than I need of copper, but let's just see if we're on the same page. I have 0.118 moles of silver nitrate, but I need 0.315, okay? So let's go back. Let's look at the copper. I have 0.157. I need 0.05. I have more copper than I need. What does that mean? Right? I have more than I need. That becomes my excess. And I have 0.118, but I need 0.315. I have less silver nitrate than I need. That's my limiting. We just figured it out. Cool. And it's as easy as that, kiddos. So let's go through another example. Here, I'll erase this so you can see that we came up with this conclusion on our own, but we can definitely clean this up so that you can see. So more copper than that is available, so silver nitrate is the limiting reactant, right? You must test one of the values using the mole ratio, assume one chemical is completely used up, and see if enough of the second chemical is present. But we did all the work for it, And if you know how to do that, if you know how to do Stoich, then you're good to go. So now it's asking, from the previous example, where 10 grams of copper reacts with 20 grams of silver nitrate, what mass of copper will be in excess? What is the amount that's left over? Well, we've already established that silver nitrate is your limiting and copper is your excess. We want to know how much extra in excess does copper have. Okay, so basically this is one way of doing it. So here's my copper, and this is what I have. No, this is basically going from here to here. This is what I have of my silver nitrate. And if all were perfect, this is exactly how many grams I would need. I would need 3.74 grams of copper would be required, but I actually have 10 grams of copper. So you can just go ahead and do that and then, oh, sorry, subtract. This is what you're given, and this is stoichiometrically how much you need. The difference is 6.3 grams. There is another way of doing this. And how much mass of silver? Oh, this is really important. The reason why we use limiting and excess is because, okay, are you ready for this? You need to use your limiting to figure out your either your precipitate or, in this case, your other metal, okay? You cannot use the excess because excess is too much. Your theoretical yield will be too high. You have to use your limited reagent to figure out the product on the product that you're looking for, either the metal or the precipitate, okay? What mass of silver will be produced? In that case, you always start with the amount of moles of your limited. This is your molar mass comparing these two, or sorry, your molar ratio, and that gets you moles of silver, and there's your molar mass of silver to get you grams of silver. But the key is you use your limited, okay? You use your limited always. Okay, there's a different way. In your notes, I have given you a different way of doing things. You can look at the notes and see if it makes sense to you. This is what I teach, and it really doesn't steer any kids wrong, but definitely take a look at your notes to see if there's a different way that works for you. Here's another one. In an experiment, 26.8 grams of iron 3 chloride in solution is combined with 21.5 grams of sodium hydroxide, okay? Right away, I know this is a limiting and excess question. Anytime you have 2 grams in your question, you're like, uh-oh, I need to figure out my limiting, because you have to use your limiting to figure out the next part. Which reactant is in excess, which we can do, and by how much, which we can do, and what is the mass of the precipitate? I need to know my limited, or my limiting, you can use either word, to figure out the mass of the precipitate. Okay, let's go ahead and figure this out. There is my balanced equation. Okay, now that I have a balanced equation, I can populate my equation. Now you're going to populate for everything. Here is the mass given, 26.8 for the iron 3 chloride, and there's my molar mass of iron 3 chloride. Here's my mass given, right, out of the question. It's out of the question for sodium hydroxide, and there's my molar mass for sodium hydroxide. I'm also saying I'm looking for the mass of the precipitate. You have to use your solubility table for that. And there's my molar mass of the iron 3 hydroxide. Okay, kiddos? So let's go ahead and figure this out. I have 0.165 moles of iron 3 chloride. Now I'm going to use my molar ratio. I need 0.96 moles of sodium hydroxide. Now I'm going to go back and do it again. Now I'm going to compare the sodium hydroxide. I have 0.538 moles of sodium hydroxide. Now, at this stage of the game, I have already more than I need, because I have 0.538 and I need 0.496. This is my excess. If that's my excess, kiddos, then my iron 3 chloride, right, becomes my limited. And this is my excess. By how much? This is something that you can do as well. You can take these moles and go ahead and subtract them, because I have 0.538 and I need 0.96 moles. If I subtract those moles, I like this way better. Here's the moles of what I have of my excess, the moles that I need of my excess, right? I subtract them. This is the extra excess. I multiply by my molar mass, and I actually have 1.7 grams extra of sodium hydroxide. You can do it that way. This is my preferred way. This is my preferred way, but you can go the other way, the previous way I showed you. That's fine too. Now what I need to do is I need to figure out how much how much precipitate is formed, and I use my limiting. Okay, so because I'm using my limiting, I know I have 0.165 moles of it, right? And here's my molar ratio, because now I'm comparing my limited to this. It's a 1-to-1. And here's my molar mass of my precipitate, which will give me 17.7 grams of iron 3 hydroxide. I know it seems kind of crazy when you look at this with all this writing, but it will clear up. So to summarize, identify the limiting reagent by choosing either reagent amount and use the mole ratio to compare the required amount and the amount actually present. And the quantity in excess is the difference between the amount of excess reagent present and the amount required for complete reaction. A reasonable reagent excess to use to ensure complete reaction is 10%. So now all I'm going to do, kiddos, is I'm going to go through the first, I think it's the first example out of your practice. All right, so let's do this together. I have 120 grams of sulfuric acid, so I'm going to go H2SO4. That's my sulfuric acid. And it's going to, and I have 120 grams of this. It's going to react with 130 grams of barium hydroxide. So I'm looking up in my data booklet, and barium has a charge of 2+. So my barium hydroxide, and that is 130 grams. I'm already writing too big. So now I'm going to create HOH plus, sorry about squishing this in here, and Ba barium sulfate, right? And there's my liquid here, and this is, I'm going to use my solubility table. I'm looking up SO4, and I notice that it's a solid, okay? So now let's take a look at the question. It says determine which reagent or reactant is in excess and by how much. I could do that. Also calculate the mass of barium sulfate precipitate by this reaction. So I am also looking for my mass, right? So H2SO4, I'm going to do the work on the side so you can see how the work is done. And then I'm going to erase it so it all fits in, okay? So now I'm going to do H2SO4. So hydrogen is equal to 2 times 1.01, which is 2.02 grams per mole. My sulfur, I'm looking it up, and sulfur is 32.07 grams per mole. Oxygen, 4 times 16. I don't do mental math, so I'm actually going to calculate that out. I knew that's what it was, but you know, I don't trust my brain. So now I'm going to add this all up, and that's going to get me a molar mass of 98.09. So 98.09 grams per mole. Now let's do it for barium hydroxide. Okay, so barium has a molar mass of 137.33. Oxygen is 2 times 16, which is 32. And hydrogen, right, because this 2 goes to here and to here, is equal to 2 times 1.01, which is 2.02. So I'm going to add all these up together with my calculator. 137.33 plus 32 plus 2.02 And that's going to give me a molar mass of 171.35 grams per mole. Okay, and now I'm also going to find the molar mass of barium sulfate, right? So barium, oops, I'll do it here. Barium sulfate. So barium is 137.33. Sulfur is 32.07. And oxygen is equal to 4 times 16, which we did already at 64. So let's add this up. 64 plus 32.07 plus 137.33. If I add this all up, kiddos, I get 233.4 grams per mole. I actually find this fun, but you know, that's just me. Okay, are you ready for some good times? Let's set it up, and then you're on your own. All right, let's go with 120 grams, and this is for H2SO4. Okay, I have 120 grams, and my molar mass of sulfuric acid, 98.09 grams per mole, right? So my grams cancel out. So with my calculator, 120 divided by 98.09, that gets me 1.22 moles, right? Times, oh, I didn't balance it. That's shameful. Let's just balance this really quick. Let's see, I have 2 hydrogens here and 2 hydroxides, so that's going to have to be a 2 here. And 1 barium, 1 barium, 1 sulfate, 1 sulfate, 1, 1, 1. That's okay. So now 1 over 1, which is going to give me 1.22 moles, right? So I have H2SO4. I need 1.22 moles of barium hydroxide. So now we're going to go here. I have, this is for barium hydroxide. I'm starting with 130 grams. I'm going to use my molar mass. 171.35 is equal to, so now grams per mole, I'm going to cancel out my grams. 130 divided by 171.35 equals 0.758 moles. I have, and this is of my barium hydroxide, right? It's 1 over 1. I need 0.758 moles of H2SO4. Okay, cool. I've set it up. So now I'm going to go ahead. Yep. Yes. Okay. So now I'm going to compare. If I have 1.22 moles of H2SO4 and I need 0.78, this is my excess. And if this is what I have and this is what I need, this is my limiting. Because I have 0.758 and I need 1.22 moles. Make sense? So for my excess, okay, someone asked me a question. What was it? What do you need? And I'm getting dinged. So let's just deal with this now. What's the question? Okay, I'm going to finish this up because you can't hear it, and then I'll record it, and then you should be able to hear it, okay? So let's just see here. I'm limiting my excess. If I take a look at my excess, I'll do this really quick. 1.22 moles, subtract 0.758. I'm going to take that answer and multiply it by the molar mass of my excess. And then to find my precipitate, I take my limiting, right, which is this guy, and I'll use that. I'll use my limiting to figure out with regular stoich the mass of this.